Hello everybody. In this video, we're going to review some of the things you learned about polynomials in Algebra 1 and Algebra 2. But the examples we're using aren't going to be the easiest examples. It's going to be some of the medium examples that you would have seen back then. To start the review part off, zeros are x-intercepts. There is a limit to how many x-intercepts a polynomial can have, and it has to do with the degree of the polynomial. So whatever the degree is, that is the max number of zeros that it can have. If the polynomial has an even degree, then there should be an even number of zeros. If the polynomial is odd, then there should be an odd number of real zeros. Over here on the left, this graph here, this one would actually be an odd function since it has 3 zeros. To find the zeros without graphing, the best way we do it is to factor it, and you find the solutions to those factors. Those solutions are solutions to whenever the equation is equal to 0. Sometimes you call those solutions roots. So we just learned like 4 words for the same thing, and those are solutions, zeros, x-intercepts, roots. They're all talking about the same thing. It's whenever the function is equal to 0. These notes are saying if you plug in a number for x, if you plug something in, if you know one of the solutions to your polynomial equation, then it's very likely that that solution can be written as a factor of the polynomial. So if you know that whenever you plug in c, it gives you a 0, then one of the factors, which are the things that we normally put in parentheses, is going to be x minus that number. And you call that factor, whenever you have the parentheses with just 2 things in there, you call that a linear factor. So if you graph a function and you get the roots from the graph, then you could turn those roots back into the factors by just putting them in parentheses with x. To help you see that, let's do this example. Alright, in this thing, if we factor it, doing our normal techniques, we would look for the thing that's in common to all of it first. For each of these terms, they have an x, so you could factor out an x. And when you factor that x that they have in common out, that would leave you with an x squared plus 5x minus 24. That can still be factored. We have an x squared, 5x minus 24. What are things that can multiply to be 24? How about 8 and 3? 8 times 3 makes 24. And for those to become a 5, we would need to subtract the 3. And now, when the two parts multiply, it makes the negative 24. If we put some x's in front, then that turns it into the linear factors, which we just saw in the previous part of the notes, that if these are the factors for the equation, then these are also how we can get the zeros. So if we take those 3 parts, if we take these 3 factors and set them equal to 0, we should get the x-intercepts. If we take the x and we set it equal to 0, x plus 8 equals 0, and then solve that by moving the 8 to the other side, so you get x equals negative 8. Then that would be one of the x-intercepts. And then the third one, x minus 3. If we set it equal to 0, and then we add the 3 to the other side, we get x equals 3 as another 0. So the 3 zeros, by factoring, were x equals negative 8, 0, and 3. And those are the solutions to the entire polynomial being equal to 0. So that's why these are called zeros. To show you again from the purple part that you could have graphed it to get these factors, let me pull up Desmos. Let me type in the equation. And we get a bendy polynomial that kind of looks like the one at the start of these notes, where it's going down from the left, it goes upwards, except it's going to get pretty high. It's going to get up to 120 it looks like, and then it goes back down. But anyways, we're not looking at the shape of this in these notes. We're supposed to be looking at the zeros right now. So let's just touch that. It says -8 is a 0, 0, 0 is a 0, and 3 is a 0. And those match what we got by factoring. You could get your x-intercepts by putting it in the graphing calculator and then taking those numbers and then turning them back into factors. To help you do that, let's do some more examples. For me, I don't want you to only be able to do something one way. I want you to be able to do something 4 different ways, so that way you can just think of whichever way seems the easiest to you or whichever way seems the easiest for the given situation. In the next example, we got an x cubed, an x squared, and an x. They all have something in common, so maybe the easiest way to factor this would just be with a common factor, taking the x, lowering the powers of all the other terms by 1. We got this new thing. If we could find something that multiplies to be -10 and adds to be 3, then those would be 2 separate factors. We want something that multiplies to be 10, and that would be 5 and 2. And how can we get the 5 and the 2 to turn into a 3? That would be if the 2 was a negative. So we factored x cubed plus 3x squared minus 10x, and we got x times x plus 5 times x minus 2. If we take these factors and set them equal to 0, then we'll get the x-intercepts. And the x-intercepts we get are from least to greatest, -5, 0, and 2. If we plug any of these numbers in, we should get the x-intercepts for the graph. Let's check it. Looking at the graph, we got x-intercept at -5, which we also got by factoring it. We got an x-intercept at 0 and an x-intercept at 2. To show you how to go straight from the graph to the roots, let me try that for the next example. For the second example, I'm going to show you how to get the roots by graphing, and then we're going to check it and make sure that you would get those same roots by factoring. So first, let's take this thing and graph it. When you're graphing this, make sure you did type it right. I just went through this example and I had typed it wrong, so I had to redo this one. We get -1/2, 0, and 3 from the graphing calculator. So that says x equals 3, x equals 0, and x equals -0.5. Those are the x-intercepts. To change these x-intercepts back into factors, then we can convert them. We'll move the right side of the equation back to the left side, so that the 3 is going to be on the same side as x, and that makes x minus 3. For the middle one, if you move 0 to the other side, it's not going to change anything. When we move the 1/2 to be on the same side of the equation as x, that gives you x plus 0.5. If we take these 3 linear factors and we just put them in parentheses multiplying each other, then it should be the factored form of the original equation. X minus 3, x plus 0.5. So to prove to you that this works, let's take the original and let's factor it the normal way. What all 3 terms have in common is an x, so we'll take the x out first. That's going to lower the power of each one of the inside terms. Since there's a 2 in front of x squared, I'm not going to factor this in my head. I'm going to use the x method of factoring. And whenever I use this method, you do a times c on top. 2 is a, the negative 3 is c, and negative 5 is b. We do 2 times negative 3, and we put that on the top to get negative 6. b we put on the bottom of the chart as a negative 5. We want things that multiply to make negative 6 and add to make negative 5. The easiest factor to check is 1 in 6. 1 times 6, we need these to be negative 6, so let's make the 6 negative. 1 times negative 6 makes negative 6, which is the top. 1 plus negative 6 makes negative 5, which is the bottom. So these factors work. There is something to remember, and that's that whenever your a is a number, like we have the number 2 here, we need to take these factors and we divide them by a. So I put 1 over 2 and negative 6 over 2. Those numbers on the left and right, this number on the left is going to become one of my factors. Let me rewrite the equation. We had an x in front, and then we just factored the 2x squared minus 5x minus 3, and our factors were x minus 1/2, x plus 1/2, because it was a positive 1/2, and negative 6 divided by 2 is going to make the factor x minus 3. And if you look at this in the blue, it matches what we got in the red. And we got the red ones by graphing, we got the blue ones by factoring. So now you know 2 ways to get factors.